Hello wonderful person, this is Anton, and today we are going to be talking about the beautiful planet Venus. And some really exciting news coming from NASA about this planet. Because after years and years of what's known as the Venus curse, NASA has announced not one, but two different missions that are going to be definitely launching in the next decade or so. Specifically in 2028 and very likely 2029. Now let's talk about these missions and also why this is so important, but more importantly let's talk about Venus as a planet and what we want to learn about it. First of all, did you know that the first flight on another planet was not actually the helicopter on Mars, but it was something on Venus? Well, most of us have already forgotten or possibly have never even known that. The first flight on Venus was the Soviet Vega probe. But it wasn't a helicopter, it was a balloon, and there were two of them launched by the Soviets in the 80s. And both of these missions survived and produced a lot of data, allowing the scientists to study the Venusian atmosphere. So this was the first official flight on another planet. And crazily enough, this was 36 years ago from when I'm making this video, so that was a pretty big achievement back then. But since then, we sort of forgot about Venus, and there's actually a really important reason for this. Well, it was actually many reasons, but the main reason is that the attention shifted to Mars. But why? It was actually because of this one very silly thing that we discovered that turned out to be nothing. Following the initial success on Venus, back in the 90s, the scientists discovered that inside this meteorite you see that was discovered in the Antarctica, which was a Martian meteorite, the scientists discovered this worm-like feature that you can kind of see right here that I've discussed in some of the previous videos, that many people believe to be some sort of a form of life that might have existed on Mars. And because of this, back in, I think it was 96 or possibly 97, okay, it was August 7th of 1996, President Clinton made an official announcement that we found life on another planet. Since then, the entire attention shifted to Mars. But then, only within a few years after this announcement, several scientists recreated these particular features, we're talking about these features, through a very simple chemical reaction, and because of this, it was then confirmed that it was not life at all, it was just chemicals. But this didn't change the fact that suddenly Mars became the place to go, everybody wanted to land there, and there were now also rovers exploring Mars and exploring various features. And because of this, Venus was unfortunately forgotten. And with the disappearance of the Soviet Union, Russia no longer had any funding to continue its Venusian missions either. And so for many years, many NASA scientists studying Venus were desperately trying to get some sort of financial support or funding from either a government organization or specifically something like NASA to try to launch something on Venus, but they've been failing year after year after year, and this became known as the Curse of Venus. Now there were actually other organizations such as Japanese JAXA that launched missions to Venus and explored it in more detail. But NASA unfortunately lost interest until today, with both of the missions that I'm going to discuss in a few seconds being some of the most complex and some of the most advanced missions anyone ever planned, which is probably why they ended up finally winning the award, the financial award from NASA. They were just too good to say no to. Oh, and by the way, they were competing for the funding from the Discovery program, which was roughly around $500 million. The program that has already officially launched the Lunar Reconnaissance Orbiter, the InSight probe on Mars that unfortunately is currently malfunctioning due to the lack of energy, and the upcoming Lucy probe, Psyche probe, and Maggie probe that I'm going to be talking about in one of the future videos. But now, as you can see, there are two more missions, DAVINCI Plus and a mission known as VERITAS. Both confirmed, both received their funding, and both are going to be launched between 2028 and 2030. And so the first mission, which is what you see right here, is DAVINCI Plus. Now this one is going to be an atmospheric lander, but it's not going to be too complex. DAVINCI in this case stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, and its main point is to go through the atmosphere of Venus and gather as much information as possible on various gases inside the atmosphere, specifically looking for various types of CO2 and CO2 isotopes, and of course also looking at various composition of the noble gases. These gases can actually help us understand how the atmosphere evolved over time and what probably happened on Venus billions of years ago. And so by collecting the information on these gases, they can easily establish if Venus one day had some sort of an ocean, or if it was always some sort of a dry, very hot and very acidic world like it is today. And because a lot of these noble gases have different isotopes as well, we normally, by studying them, can tell where they came from. So for example, if there was an ocean a long time ago, we'll be able to identify certain isotopes that should be present in the Venusian atmosphere. So for example, it's going to have certain amounts of xenon, certain amounts of argon, and certain amounts of helium. And because scientists today, based on what we have on Earth, know exactly where various isotopes of these noble gases usually come from, it's going to be an extremely effective way for the scientists to study the history of Venus as a planet. And so, for example, we know that helium-3 that you can see on the left usually comes from the deep interior of the planet, whereas helium-4 on the right usually comes from the upper crust. Depending on what the scientists discover more in Venusian atmosphere, they can then determine what the planetary activity was like. Were there a lot of volcanoes going on, or was Venus more or less static and did not have as much activity? And because noble gases generally do not interact with carbon dioxide, water, or really pretty much anything, they kind of just stay in the atmosphere, not reacting with anything, and thus can be used to study the history of the atmosphere. More importantly, allowing us to understand where exactly these gases came from and what happened to Venus in the past. But the location where this mission is going to be landing is also very important. It's going to be studying these really mysterious and very strange structures known as Tesserae. These are unusual formations on the surface of Venus and seem to only exist on this planet, but nobody really knows or understands where they came from. In this image right here, you can kind of see some of them underlined in white. And VERITAS is going to be basically aiming for one of these structures, and so when landing there, it's going to be able to take some of the most high resolution, some of the highest quality pictures of Venus we've ever had, and also pictures of those Tesserae. Now, because some scientists believe that these Tesserae represent potential continents that used to exist on Venus, this could actually allow us to understand if Venus one day had plate tectonics. Did it have continents like Earth? And if so, why did they suddenly stop? So this is one of the more important parts of this mission. At the same time, by using other sensors, such as the infrared sensor, is going to try to map the nearby region, providing us an extremely accurate topological map of the region where it lands. And because it's also going to have an orbiter that's going to stay in orbit and communicate with this particular probe, this will present a perfect opportunity to map a lot of regions and to try to understand what exactly happened on this planet a long time ago. But as you can probably imagine, this probe is not going to survive for a very long time. Just like the Soviet probes back in the days, there's a very high chance it's not going to be built to survive longer than a few hours or maybe maximum a day or so. It's not unclear if this is going to be using some of the materials I mentioned in one of the previous videos that can survive in these hellish conditions, but right now the scientists are planning to use just the regular silicon-based materials that are not going to be very durable. Although because there are still like 8 years to go, chances are everything might change. And one of the reasons why it's still going to be probably using silicon technology, which usually stops functioning once temperatures reach about 250 degrees Celsius, is because we don't really have a functioning radio that works at higher temperatures. And this probe needs to be able to send us a lot of data and a lot of information very quickly. Because of this, we still have to rely on the old technology for now. And so the DAVINCI mission is going to be studying the history of Venusian atmosphere and to some extent also the history of possible plate tectonics on this planet. But then the other mission, the mission known as VERITAS, is going to be an orbiter, and this one is going to only have one main purpose. As you can probably tell from this image, it's going to map everything. It's going to use a lot of different advanced technology, including infrared and radar technology, to map as much of the surface as possible, even piercing through some of the upper layers. Which is going to be very similar to that lunar map I've discussed in one of the previous videos that allowed the scientists to identify everything, including the type of rock in certain locations. And all of this is going to be done in possibly a few years after the mission is launched. For this, it's actually going to be using some of the sensors from the French agency and from the German agency, so technically this is going to be an international collaboration. And because our current map of Venus kind of looks like this, and it's extremely low in detail, and really is based on some of the older studies from decades ago, the VERITAS mission is going to be extremely important in helping us map and also understand what happened to Venus in the past, and what's happening on it right now in the present. Basically, is it still active? Are there still volcanoes? Is there still a lot of activity on the surface? Are there some unusual supercritical lakes or liquid carbon dioxide lakes? Or is something else really mysterious going on here? And this is of course super important to understand, because if you look at this, the comparison between Earth and Venus, size-wise, mass-wise, and even density-wise, they're extremely similar. But something happened here, and we're sort of worried it might also happen here. And because of this, the scientists really want to understand what exactly happened to Venus in the past to turn it into that hellish, high-pressure, high-temperature, high-acidity planet. So for example, was it because of the carbon dioxide release and the so-called greenhouse runaway effect? Was it because of some other event that somehow shut down the terrestrial activity and the plate tectonic? Or was it because the sun got hotter over time and eventually a lot of the early atmosphere escaped, creating the atmosphere that it has today? So all of this is definitely going to be hopefully answered in the next decade or so, once these missions make it to Venus and get a few years to collect some data. And the data that we're going to get from there is going to be absolutely mind-blowing. So right here, what you're seeing, this is from 1989 and technically from the early 90s. This is from the NASA's Magellan probe, the last probe that got to map the Venusian surface. And remember, this was almost 3 decades ago. With the current technology that we have today, and with the ability that we have to map a planet or a moon from the orbit with such extreme precision, the details we're going to be getting from VERITAS mission at the end are going to be absolutely mind-blowing. So this right here is definitely going to be one of the most exciting missions in the next decade or so. But I guess one question here is, are they going to be also looking for phosphine or potential life? Well, the answer to that, for now at least, seems to be no. And mostly because phosphine and the idea of phosphine in Venusian atmosphere is more of a recent discovery. When the scientists were planning these missions and were officially applying for the funding from NASA, they didn't really know phosphine was even a thing in the atmosphere. Which also means that there's a chance they might actually attach some sort of a sensor or some other additional probe in order to potentially test Venus for the presence of bacterial life in the upper atmosphere. And discovering life here would be absolutely mind-blowing. Mostly because a lot of scientists today, or at least some scientists today, still strongly believe that the Venusian atmosphere has the capacity to actually support life in the upper atmosphere, and many scientists have been arguing that we know that life is there simply based on the observations from before. For example, based on the recent observations from the Japanese Akatsuki probe, they discovered unusual patches of ultraviolet absorbers, as if something unusual was collecting ultraviolet light in the upper atmosphere of Venus, and some scientists propose that this was a sign of bacterial life, most likely just collecting light to survive. But we obviously will not know any of this until an actual exploration of the atmosphere and the collection of the atmospheric sample, and possibly some sort of a test to determine if it's life. We don't really know if it's going to be done. Chances are it might not be these missions, but hopefully someone will test the atmosphere sometime in the future. Until then though, these missions are already super exciting. They're going to allow us to learn so much more about Venus we didn't know before, and more importantly, we're going to learn so many more details that might help us see what might happen to our own planet. Venus is believed to be very similar to planet Earth, but it's sort of turned into something completely different. And so learning the reasons behind this are very important. Approximately a decade ago, NASA released this beautiful video that you can find in the description below that essentially was a kind of an inspiration to try to return back to Venus. It was an attempt to encourage scientists and to encourage the NASA administration to form some sort of a mission to possibly get funding and to try to launch a spacecraft in order to investigate our beautiful neighbor and to learn its mysteries. Hello wonderful person, this is Anton, and today we're going to be talking about Venus once again, because something else absolutely incredible was discovered about it relatively recently. So, a decade has passed and NASA finally got its wish. We have 2 NASA missions and 1 ESA mission going back to Venus in less than 10 years from now. And all 3 missions are going to be really exciting because we're going to be able to discover a lot of new things about this beautiful planet. But what makes Venus exciting? Well, there's only one image you need to see to try to understand all of this. Or in this case, it's the simulation from Universe Sandbox. We have Earth, Venus, and Mars. Notice how Earth and Venus are pretty much exactly the same in terms of size, mass, and even density. They're literally sister planets. Mars, on the other hand, is a lot smaller, it's also a lot less dense, and overall is really not as exciting of a planet compared to, of course, Venus. Venus seems to be that one object that can actually help us answer a lot of questions about our own planet and possibly even help us understand how life formed on Earth and if it one day existed on Venus as well. Venus is a lot more exciting in every respect. And so all 3 missions are going to be hopefully answering all of these questions. While at the same time going to Venus will definitely propel us to a completely new generation of technology as well. I've actually discussed this in one of the previous videos that you can check out on the channel. It's going to be popping up somewhere right there. But to try to understand the importance of Venus and the missions to Venus, let's talk about our own planet. So when it comes to planet Earth compared to some of the other planets, there are a lot of features that our planet has that no other planet or moon has in the solar system. One of these major features is what we refer to as plate tectonics. The idea represented in this simulation right here that sort of shows you that the planet is technically divided into these plates. And these plates, they move around, they interact, they also create all sorts of geological features. And today we also believe that they're responsible for recycling a lot of the material from inside the planet to the outside and vice versa. And though on the one hand they're also responsible for a lot of earthquakes and a lot of volcanoes, on the other hand, plate tectonics and the interaction of plates is believed to be absolutely crucial for the survival of life on our planet and for the relative constancy of the climate on our planet in the last billion years or so. And going further, it's even believed that one of the reasons why Venus became so extremely hot and so extremely thick in terms of the atmosphere is really mostly because of the lack of plate tectonics, the lack of this geological activity that would otherwise protect this planet and would otherwise maintain somewhat habitable conditions on the surface. And so plate tectonics in this case is sort of the key feature. But the question is Venus indeed inactive in terms of plate tectonics, or is it something that we just don't really understand well? Well, one important feature that was discovered not so long ago, something that's also visible right here, is the potential presence of still active volcanoes or volcanoes that were recently active, suggesting of course that something geological is still going on the surface. A lot of previous studies have also discovered that Venus was definitely volcanically active in the last few 100 million years or so, and several major volcanic features have already been discovered there as well. But interestingly enough, some of these volcanic features appear to be relatively recent. But how recent is of course a question we cannot really answer until we go in there and investigate it in more detail. But the scientists behind this recent paper discovered something else that nobody has ever seen before. They've discovered these unusual features you see right here, a lot of which were located in the lowlands of Venusian surface that indicated some sort of large-scale movement that produced a lot of deformation and signs of shear stress, kind of similar to what you would expect from really large chunks of ice or really large ice cubes, as they slowly move around grinding and rubbing against each other, which implies that there's definitely motion and possibly some sort of a geological activity on the surface of Venus after all. Very likely driven by very similar effects like on planet Earth, from the activity of mantle and the heat exchange that produces a lot of churning on the inside, which then releases the energy and provides the motion for the plates on top. And one way they try to prove this is by actually modeling some of their observations and creating models here on planet Earth. And by using mathematical flow models, they were able to match the observations to some sort of a motion of large chunky plates similar to thick ice cubes floating on the surface of water, which were most likely driven by internal convection and creating a lot of this deformation that was then visible on the surface of Venus. Or in other words, unlike planet Earth where the plates are just these large chunks that are relatively thin in size, it looks like Venus might possess these smaller cube-like objects, or not necessarily cube-like but just chunky objects that are floating on top of Venusian mantle and are still interacting with one another, producing all sorts of shear stress that's visible on the surface afterwards. And what's more is that a lot of these features definitely appeared after the last volcanic activity, which of course implies that a lot of this is more or less recent. If the volcanoes are recent, then a lot of these shears that have formed, for the most part, are also more or less recent features as well. Although when I say recent, I mean in the last few million years or so. And if this discovery is correct, and if what the scientists discovered is indeed what's happening on the surface of Venus, this actually makes Venus even more exciting, mostly because it seems to be this unique tectonic object. It's not as inactive as, say, the Moon or Mars, where there's really nothing happening, But it's also not as active as Earth. It's something in between that has its own thing going. But more importantly, it might also show us what happened to Earth a few billion years ago. So first of all, generally speaking, the thickness of the plates, the so-called lithosphere, depends on its temperature. And the temperature usually is affected by what happens inside the planet. But since in the past Earth used to be much hotter than today, we believe that the heat flow from within the planet to the outside was about 3 times higher than it is today. Which also means that the lithosphere of ancient Earth might have, sort of, been somewhat similar to the lithosphere of modern Venus. Or not thick enough to form actual plates like what we have on Earth today, but thick enough to form these large fragments to bounce around, to rub against each other, and to form various structures that we observe on modern Venus as well. And so ancient Earth might have been like modern Venus, which is actually something really exciting if it's true. It means that maybe one day Venus will evolve into something similar to planet Earth, and possibly even become habitable once again. At least that's one of the potential explanations. It could also be the other way around. Maybe Venus actually lost its plate tectonics and has now started to get these unusual fragmented formations on the surface. So there's definitely a lot of things to discover here in order to understand what happened to Venus, just so that we can understand where our own planet is headed as well. A lot of really interesting questions can be answered by directly and thoroughly studying the surface of Venus and trying to understand what happened to Venus in the past. But until these future missions in the next 10 years or so, and until we physically launch more spacecraft and possibly even manned mission to this unusual planet, we're not really going to know much else. And speaking of manned missions, a few years ago NASA had this really cool proposition, the video for which you can find in the description below, on how we could potentially launch manned missions here with a return craft that would be really awesome. And in this case, the craft itself would be a kind of a Zeppelin that would move around Venus launching all sorts of different probes, with pilots basically just living on the balloon itself. But once the mission was finished, they would launch a return craft, which would then return them back to planet Earth, and return all of the samples and all of the discoveries there as well. Now unfortunately, after about 7 years, nothing really came out of this, but this would be a really awesome mission if it actually did happen one day. You can check out this video in the description below as well. But I guess until future studies, until future discoveries, and until these missions actually happen, we're going to be slowly learning about Venus by just studying some of the old data. Once we discover something incredible, I'll make sure to follow this up in one of the future videos. I've been really looking forward to a lot of these Venusian missions, and I'm super excited. We're kind of going back after all. Hello wonderful person, this is Anton, and today we're going to be talking about our nearest neighbor, Venus, and some really fascinating discoveries coming from the atmosphere and also from the surface of this beautiful planet. And more specifically, we're going to take a look at one of the discoveries from Parker's solar probe that flew by Venus back in 2020, and also the radar observations from Green Bank telescope that allowed the scientists to very precisely measure the length of day on Venus, while also discovering that the day on Venus actually changes quite a lot depending on the atmosphere, with some of the findings being a little bit unexpected. But first of all, let's take a look at the planet itself. As you can see, we can't really see much on the surface. The atmosphere here is so thick and there are so many clouds everywhere that it's almost impossible for the scientists to visually observe what happens on the surface. And because the atmosphere here is very reflective, it essentially is impossible to study this in optical light. So different frequencies of light have to be used in order to penetrate this whole layer. And this is actually one of the reasons why Arecibo Observatory was so important here. Because this was actually a radar observatory, it was able to penetrate the layers of clouds on Venus, and after a few decades of observations, was able to create the surface map of Venus that we have today. But these observations have not stopped. Even though Arecibo Observatory is no more, there are 2 more telescopes in the US that have been doing a pretty good job at doing these radar observations. And here's how all of this sort of looks. Now this is the Goldstone and the Green Bank observatories, and essentially they use radar communication or radar pulsations to try to scan the Venus or the surface of Venus, and as the photons return to Earth, they essentially allow us to map pretty much everything on the planet. Now these 2 observatories are located relatively far away from one another, And because of this, the actual arrival of these photons is not instant. It takes approximately 20 seconds between the observatories. Because of this 20-second delay, it allows the scientists to extremely precisely measure everything about the spin of Venus, because the reason why these observations happen with a 20-second delay is due to a very slow rotation of the planet, and so this allows the scientists to precisely calculate the spin of the planet. And after approximately 15 years of observations, the scientists created a really accurate map of Venus and precisely calculated the spin and the changes of the spin of the planet itself, which also allowed them to calculate the tilt of this planet and the approximate size of the core inside the planet as well. And because of these very precise observations, we now have a lot of details we've never had before, and it also allowed us to answer a very interesting mystery about Venus. For some reason, over the past few decades, when the scientists measured the length of the day on Venus, it never really added up. It was always a little bit different, and sometimes different by as much as 20 minutes. And although at first the scientists thought that maybe it's because of errors in our observations, today we know that this is not the case. Venus seems to change the length of the day by as much as 20 minutes, meaning that sometimes when we look at Venus, the day might be about 20 minutes shorter than in some other times. Now, considering the fact that the day here is really long, this actually doesn't really change much for Venus. Compared to a single 24-hour day on our own planet, the new calculations from Venus suggest that the day is exactly 243.0226 days, roughly equivalent to about 2/3 of Earth year. And so a 20-minute change here is going to be really difficult to notice. But it is nevertheless there, and we now understand why this happens. The reason is really the atmosphere itself. Because it's over 90 times as heavy as the atmosphere of our own planet, as the planet and the atmosphere spin, there is a lot of trade-off of momentum. Now, our planet Earth actually has very similar effects, and the atmosphere of Earth does change the day on Earth just a little bit as well, but because the atmosphere of Earth is so much thinner, it only adds like a millisecond per day. And that's actually something I've covered in one of the previous videos a few months ago. You might be able to find it somewhere right there. But the extremely thick atmosphere on Venus has so much momentum as it spins with the planet that the exchange here is a lot more dramatic and thus slows down the planet a lot more, or sometimes it accelerates it as well, depending on what's actually happening to the atmosphere and of course depending on the so-called seasons. Which by itself is a really incredible discovery and finally answers why the measurements of the day on Venus were so different depending on when we were looking at it. At the same time, the axis of this planet has also been calculated extremely precisely, and the angle of axis here was found to be approximately 2 degrees, whereas on Earth it's about 23 degrees. And as you probably know already, the axial tilt influences various seasonal changes on our own planet. And just like Earth, Venus also has what's known as precession, where the axial tilt changes over time and sort of does this, and we actually refer to these as Milankovitch cycles. On Earth this happens every 26,000 years, but on Venus this seems to be about 29,000 years. Although how this affects the planet is not really well understood just yet. And by combining all of these observations, the scientists were also able to work out the size of the core inside the planet. It seems to be about 3,500 kilometers across, which is very similar to planet Earth as well. But it's unknown if the core here is liquid or solid, with the more likely answer being a solid core because there doesn't seem to be any magnetosphere or magnetic field around the planet as we have on planet Earth. But by using this technique, the scientists can now actually use this on other objects, like for example on various moons of Jupiter and Saturn, to establish what happens underneath the ice. They might even be able to measure the depth of various oceans on those objects. So this is a really interesting technique, and it will definitely allow the scientists to sort of pierce through various layers of various objects and detect things underneath. But this was not the only discovery coming from Venus. As I mentioned, there was also a discovery coming from the Parker Solar Probe, and this was in regards to the atmosphere. Now, as you might already know, Parker Solar Probe is slowly coming closer and closer to the Sun. But to do this, it needs to pass by Venus in order to perform what's known as a slingshot maneuver and then lose a little bit of speed and come closer to the Sun. It's going to be doing this 7 times in total, and it already did 3 of these maneuvers. The third maneuver allowed the probe to pass through a region of the atmosphere roughly around 800 kilometers above the surface of Venus. You can sort of see it passing right there. and during the passage here it actually entered the ionosphere of this planet, which is created around Venus through the interactions with the solar particles. It's actually a really interesting topic, but there's going to be another video about this later on. And anyway, as it passed through this region, it was able to hear something, and the scientists knew exactly what they were listening to, because they've heard this many times before around other objects like Jupiter. But first of all, here's what all of this sounds like. This is basically what the scientists heard. Now, all of this is coming from an instrument known as FIODS, which is supposed to be measuring magnetosphere of the Sun, but it can obviously measure magnetospheres of other objects as well. And during the passage for about 7 minutes, it was detecting this signal around Venus as well. A signal that resembled something very similar that the scientists heard when the Galileo probe passed by Jupiter many years ago. And all of these sounds that you heard was formed by electrically charged layer of gas in the upper edge of the atmosphere, which allowed the scientists to very precisely calculate the density of ionosphere of Venus. And when they compared this to the values measured back in 1992, this was by the mission known as the Venus Pioneer Orbiter, to their surprise the observations were slightly different enough to suggest that the ionosphere of Venus changes quite dramatically, which of course very likely depends on the solar cycles that create the ionosphere to begin with. During 1992 mission, this was the period known as the solar maximum. The Sun was emitting a lot more charged particles, and as you can see in this graph, this was actually one of the highest solar maxima we've had in a while. But the 2020 mission was during the solar minimum, which means that the Sun was producing less charged particles, and thus allowed the ionosphere to shrink quite dramatically as well. Which of course implies that the ionosphere here can actually shrink or increase in size by a huge margin, depending of course on the solar cycle and the emissions from the Sun. And although the atmosphere itself doesn't change that much, the ionosphere does, and this will very likely influence a lot of other interaction. And although the atmosphere itself doesn't change much, the ionosphere does change, and very likely has a lot of other effects on the surface of this planet as well. And because a lot of the gas and a lot of material is usually lost through the ionosphere, it's very important for the scientists to figure out how all of this sort of interacts and how many of different gases are lost in the process. Luckily for us, in about 3 years, the Parker Solar Probe is going to be doing its final 7th approach to Venus, and is going to be even lower in the atmosphere. It's going to pass just a little bit under 400 kilometers above the surface. And during this passage, it's also going to be during a much more active Sun, essentially in the middle of the solar cycle, which will allow the scientists to study the atmosphere of Venus even more and most likely uncover some really interesting surprises. And studying this is very important because it allows us to understand how planets lose atmospheres, or how some other planets are able to maintain very thick atmospheres over long periods of time without any magnetosphere, such as of course Venus. Hello wonderful person, this is Anton, and today we're going to continue our discussion of Venus and some of the recent advancements, including some of the recent discoveries from this beautiful, mysterious planet. But more specifically, all of this of course relates to the recent discovery of phosphine gas in the atmosphere of Venus. So let's talk a little bit more about this in more detail. First of all, I actually wanted to highlight this tool that I've been using for many years now, the tool known as NASA's EYES. This is an absolutely free tool made by NASA many years ago and has been regularly updated to add additional missions, additional observations and discoveries. It allows you to explore the solar system, our planet Earth, and of course the rest of the galaxy that we've discovered so far. But in this particular case, you can also see what Venus looks like without the atmosphere. And because this tool is absolutely free, I actually recommend that you check this out by yourself as well. But let's talk about Venus. So this image right here was created by the only mission we currently have around Venus, and this is by the Japanese JAXA, the Japanese Space Agency, and the mission known as Akatsuki, which has been exploring the Venusian atmosphere and creating all sorts of observations, mostly in ultraviolet light, of various types of atmospheric conditions on the planet. Unfortunately, however, it's unable to detect the chemical composition of the atmosphere, and it's also unable to see any of the more advanced things that we'd like to see in order to explore the discovery of Phosphine, or in order to see if there's any life out there. And because its primary mission has always been atmospheric exploration, it's not really going to unfortunately help us to confirm or to deny the existence of life on Venus. Nevertheless, it's been helping us understand how the atmosphere of Venus works and what's happening with all sorts of storms that we've detected on Venus and all sorts of wind activity as well. There is, however, one hope, and that's from a completely different mission that's going to a completely different place. A mission that's going to pass by Venus around mid of October 2020, and then once again next year around the same time. One of the previous videos that's somewhere right there is actually about this mission, and it talks about its main purpose, which is to go to Mercury by roughly around 2025. But to get to Mercury, it's going to be using a lot of gravity assist maneuvers, and it's actually going to be using Venus twice. And the first passage around Venus is going to happen very soon, only in a week from when I'm making this video, and has most likely already happened if you're watching this in my future, technically your present. And it just so happens that the mission known as Bepi Colombo may contain the necessary instruments to at least try to confirm or deny the existence of phosphine and possibly even the existence of microbial life in the atmosphere of Venus. Now, the first flyby that's going to happen in roughly around a week is going to be at a distance of, I think, about 10,000 kilometers, so that's actually kind of far away. That's maybe about this far away from the surface of the planet. And from this distance, it might be kind of difficult to probe the atmosphere itself, or to try to see what's underneath the atmosphere. But in the next few months, the scientists behind this mission are hoping to develop a good enough technique to try to conduct better experiments in 2021 when the second approach to Venus occurs. The second approach will be as close as about 500 kilometers away from the surface, and this will be close enough to conduct a lot of different tests of the atmosphere and to potentially discover something in the upper atmosphere of this beautiful planet. In other words, as early as late 2021, we might finally have the answer to the question of, is there life on Venus after all? And honestly, I've been really excited to see Venus finally trending on the internet, and a lot of people have been super excited to talk about it, to present all sorts of ideas. And interestingly, even on Reddit, one of the biggest trending pictures in the last month was a map that someone created, by the way, you can also find this in the description below, that presented a hypothetical Venus with water on the surface. In other words, what would Venus look like if it had a liquid ocean? Naturally, I tried to recreate this myself, although for some reason, my Venus looks entirely different. Mostly because of, I guess, the topography in this particular simulation, where it doesn't really create these deep oceans visible on the map right here. My Venus seems to possess a lot of smaller lakes and smaller seas everywhere, but no big oceans whatsoever. Although honestly, it still looks pretty cool. Now, obviously this is not something we're going to be finding on Venus, and it's probably not something that's going to happen to Venus in the next few hundreds of years, even if we try really hard to somehow terraform it. And by the way, one of the reasons why it's going to take so long is because of the heat that's currently present there. Even if we somehow start reducing the amount of CO2 in the atmosphere of Venus, it will unfortunately take this planet up to 100 years to cool down naturally and to lose all of its heat. There's a lot of heat stored here, and this planet has very high heat capacity. And also, although not related to this, there have been a lot of really interesting studies that have found several different efficient techniques to how to convert CO2, carbon dioxide, into other things, like for example things like methanol or even things like plastics, which has actually been suggested in several different papers, with several techniques requiring nothing but copper wire, and using this as a catalyst, we could technically turn the entire atmosphere of Venus into huge mountains of plastic. Now that could make a pretty cool science fiction story, although I'm not really sure how likely any of this is going to happen anytime soon. Anyway, so we've definitely been discovering a lot of ways to convert CO2 into different things, so maybe one day terraforming Venus might become a reality. But for now, we're more interested to discover if there is actually anything living there already, because if there is something there already, it might not really be appropriate to try to turn this planet into something different. But that's of course not it. I kind of left the more exciting announcements for the end. First of all, a very recent paper that came out only a few weeks before the Phosphine announcement provided an absolutely brilliant explanation for how bacterial life could survive on Venus for many millions and even billions of years. And this paper is by the brilliant MIT professor / NASA scientist Sarah Seeger, who's been doing research on all sorts of exoplanets and all sorts of other potentially habitable planets for many years now. In other words, when it comes to studying alien life and the existence of alien life somewhere out there, she's basically the expert. And here's what the team behind the paper proposes. Essentially, for any kind of a bacteria to survive on Venus, they would most likely need to survive inside tiny droplets of water. And similarly to water droplets in our own atmosphere, these would circulate in the upper atmosphere, slowly becoming bigger and bigger as they combine with one another. And for as long as these droplets exist, the life inside these droplets would most likely be able to thrive and to possibly even evolve into something more complex. Eventually though, these droplets would get large enough that the gravity of Venus would start attracting them closer and closer to the planet. When this happens, the droplets would reach the point in the Venusian atmosphere when they would most likely start evaporating. And this would happen maybe 30 to 40 kilometers above the surface of Venus, at which point all of the bacteria that were present inside these droplets would essentially start to dry out, to desiccate, and to release all of the bacteria into the Venusian very unfriendly atmosphere. But just like the bacteria on Earth, this bacteria would most likely simply desiccate. They would turn into the bacterial spores. They would not really die. And as a result, they form really large quantities of particles that could also then be responsible for the haze we're observing in the lower atmosphere of Venus. Which is of course one of the reasons why it's so difficult to see the surface here. It could be completely hidden by the haze of these bacterial spores, although it's not certain how much of this would be spores and how much of this would be something different. Eventually, because of the motion of the atmosphere, some of these spores will return back into the upper atmosphere and get reabsorbed by other water droplets, thus restarting their cycle once again. And although these droplets may only exist for like a few months or so, it might be enough for the bacteria to kind of restart its cycle, to procreate, to evolve, and to continue its existence for millions of years. And in that sense, this paper came at just the right time to explain what we might be observing on Venus, because it's maybe how this bacteria is able to create so much phosphine, and this would also explain a lot of other observations, including the haze and the unusual clouds known as UV absorbers that have been observed for many years now. So in terms of the theoretical explanation, the theory is very solid. Life should be able to exist here, no problem. But who's going to be the first to find it? Well, it's very likely that even before Bepi Colombo, that's going to be able to analyze the atmosphere in 2021, this brilliant man might beat them. This is Peter Beck, and just like Elon Musk, he started a space company. The space company known as Rocket Lab. Their rockets are much smaller, they're much more satellite oriented, and they're also a lot cheaper, and they tend to launch smaller satellites. But they're also a lot more affordable and are very specific to the industry of microsatellites. As of October 2020, they launched 55 satellites already, and it just so happens that only a week before the Venus announcement, they also announced their new platform, their new idea for a satellite known as Photon. The new satellite system able to launch much smaller satellites into higher orbits, into the orbits around the moon, and of course be able to go to Venus as well. And this is exactly where it gets really exciting, because very recently Peter Beck announced that he indeed wants to be the first to go to the moon and to try to find out if life is really there. And their Photon is perfect for this, because they're essentially able to launch a relatively small satellite, possibly only the size of a tiny cube satellite, approximately 30 centimeters or 1 foot in diameter, and maybe about 30 kilograms or 80 pounds in mass. So it's a very small object, but it should be enough for us to get all of the data we need and learn more about the Venusian atmosphere and if life is really there. And it just so happens that right before the Venusian announcement, the Rocket Lab has already tested their Photon and it seems to work brilliantly. All they have to do now is create an actual satellite with the right components that can do all of the science that's needed to be done on Venus in a very short time period. Because the mission profile here is really simple. They're going to launch this tiny satellite to Venus, it's going to enter the atmosphere of Venus, and it's going to have approximately 5 minutes to analyze everything before it dissipates into nothingness. or at least before it gets crushed by the tremendously high pressure and gets dissolved by the acid in the atmosphere. And in that sense, right now there is very little stopping Peter Beck from becoming the first to confirm life there, and so there is definitely a lot of excitement about this mission. So the only thing they're really lacking is the right instruments and the right satellites to do all of this really quickly and to send all of the data back to Earth. And as it looks right now, this mission might be possible before 2023, or even earlier than that if they're able to come up with everything in the right time, which would of course be a really important boost for the Rocket Lab as a small startup. Not only is it a great commercial for the company to find life on another planet, it's also an extremely important proof of concept suggesting that these missions can be really cheap, only a few $1,000,000, which might not sound cheap, but compared to other launches, this is hundreds of times cheaper. And this of course means that in the next few years we might have a lot of exciting news coming about Venus, and it's also possible that in the next 3 years we might finally discover life on another planet. And like I said many times before, it's definitely not going to be Mars. It's going to be the sister planet Venus. Hello wonderful person, this is Anton, and today we're returning to Venus once again. Now interestingly, this indescript planet you're looking at, that's essentially Venus. This is what Venus looks like in a telescope. Although in reality, because it reflects about 90% of light, it's actually a little bit brighter even. Hello wonderful person, today we're talking about another discovery coming from this beautiful planet, and another discovery that once again suggests something unusual, possibly life-oriented, is happening in the atmosphere of this unusual, somewhat deadly, but also somewhat mysterious planet. So it looks like we've discovered an amino acid known as glycine that surprisingly is very prominent in pretty much every type of life here on the planet. As a matter of fact, you and I right now contain a lot of this glycine in our bodies. One of the most common proteins in our bodies is this right here. This is called collagen. The protein responsible for a lot of different activity in our bodies and something that's essential for our skin, for example. And around 30% of our body is made out of collagen. At the same time, about 30% of this protein is made out of glycine, which also suggests that about 10% of our bodies is made out of this amino acid. And even though there are roughly around 500 to 600 amino acids we already know exist in nature, only about 20 amino acids are used by life, including of course us, and this is one of them. So naturally discovering something like this in an atmosphere of another planet is of course extremely exciting. But here we have to be very careful, because first of all, glycine has already been discovered in, for example, asteroids and comets. As a matter of fact, this comet right here, 81P Wild, is one of the comets where glycine was streaming out at all times. So we do know that glycine exists in space. We also know that it exists in different types of rocks and different types of ices orbiting in space, but we've never really found it on another planet. Like for example, there doesn't seem to be glycine on Mars, at least as of now, and there doesn't seem to be glycine present in either the atmosphere of Jupiter, Saturn, Uranus, or Neptune. And obviously Mercury doesn't have any glycine either. So discovering this amino acid that's present in all of the or most of the life on Earth, and also finding it in the atmosphere of the nearest planet to us, where we've already discovered signs of potential life, is of course a telltale sign of something strange happening here. Now, since the original discovery of phosphine in the atmosphere of Venus, there have been a lot of follow-up papers, and most of these papers so far are trying to investigate the reality of the discovery, but also are trying to find if phosphine could be produced in some other inorganic ways. One of the recent papers, for example, investigated the idea of volcanic reactions and various types of volcanic eruptions on the surface of Venus, trying to find a potential chemical way where phosphine could be generated naturally. And this is actually related to a lot of the comments I've been getting from you wonderful people, especially those of you familiar with chemistry in general, who did point out that, well, there are actually chemical ways for phosphine generation by essentially turning the phosphides, which could be produced by volcanoes, into a type of a phosphoric acid first, and then having that acid disintegrate into phosphine under high temperatures. However, As of right now, the scientists behind the original phosphine discovery still suggest that such reactions would not really be probable in the atmosphere. Personally, I definitely have to do a little bit more chemical research here to discover what exactly it is that's stopping these reactions from happening naturally. For now, we're just going to leave it at that because there are going to be more follow-up papers with more actual chemical investigations of what can and can't happen in the Venusian atmosphere. We're still not entirely clear on how much phosphorus acid there is in the atmosphere. And so while the scientists are figuring out if phosphine could be produced by volcanoes that essentially react with water in the atmosphere and turn phosphorus acid into phosphine, let's really talk about what the scientists discovered now. So glycine, as I mentioned, is a ubiquitous amino acid. It's also the simplest amino acid we have. But despite its simplicity, it is absolutely essential for the proper functioning of many different proteins, and it's the reason why certain proteins are able to create these structures right here, known as alpha helices. In other words, despite its simplicity, it is fundamental to the creation and the complexity of life on our planet. It also seems to have other specific needs for humans as well, like for example, it seems to act as a neurotransmitter and thus play an important role in the neuron activity in our brains and of course other parts of our bodies. But even though it's everywhere and also is extremely important for life, it's not really a biosignature. In other words, it's not necessarily a sign that life is actually happening in that particular location, in this case, the atmosphere of Venus. So even though we've discovered glycine in the atmosphere, and even though we've possibly even found phosphine here, this does not necessarily mean that life was discovered for sure. These are still just independent signs that possibly suggest life, but none of this individually shows us any proof. Nevertheless, there are still some very interesting correlations in their discovery in comparison to the discovery of phosphine. For example, just like phosphine, it was also located in a relatively similar part of the atmosphere, and both the phosphine and the glycine were also mostly found along the equator, not so much, actually not at all, at the poles. In other words, the correlation in the amount of glycine and phosphine was actually quite high in terms of the presence in the same regions. And although here on Earth glycine and phosphine could be potentially signs of life as well, in this case, the natural explanation is still possible. Like for example, the reason why it could only be present in the equatorial and not the polar regions, as also mentioned by the authors of this paper, is in regards to how atmosphere circulates on our own planet as well. The so-called Hadley cells that you see right here generally push the atmosphere toward the same region and normally toward the equator. So in this region here, you would actually find a lot more different types of mixing and different types of activity, as opposed to in the polar regions where the actual mixing is much lower. So the combination of the slow rotation of Venus with unusually fast winds on Venus could theoretically create Hadley cells that would just push all of the materials toward the equator, and all of the chemicals released by the volcanoes would just end up in the equator as opposed to ending up in the polar regions. Yet at the same time, the Hadley cells on Venus would most likely take around 70 to 90 days to circulate the materials here, and this would technically be more than enough for a typical bacterial life to go through all of its cycles of replication and even evolution, and to then spread to other parts of Venusian atmosphere. And the other really unusual correlation is actually in the shape of this graph that you see right here. This shows you the distribution of, as you can see, glycine and phosphine. And the distribution of both of these materials seems to match in terms of the shape of altitude versus the mixing ratio. In other words, what this graph tells us is that they do seem to correlate with one another quite directly. In other words, whatever is producing phosphine could possibly be exactly the same way that the glycine is produced as well. Now that is actually what makes this extremely interesting, because on the one hand, this is a direct suggestion that this could be life-related. But on the other hand, we could have also discovered some unusual chemical reaction that we've never even thought of before, a reaction that could also be volcanic in origin, that first of all could possibly have nothing to do with life, but second of all would definitely help us understand how these materials are produced in other conditions. And for all we know, we could maybe find a way to use this to produce certain materials here on planet Earth as well. But just a quick reminder, we can't really rush and say that this is a life for sure. Just like with the discovery of unusual formations inside this asteroid right here, where something that resembled life was discovered in the asteroid, I think about 2 decades ago now, back in 1996, and was also an official announcement of the discovery of life on Mars, this turned out to be not really true. This was a chemical reaction producing these, and we were able to successfully recreate them here on Earth as well. We also know that the famous Miller-Urey experiment was able to kind of recreate these initial conditions on planet Earth by combining all of these chemicals with electrical discharge, and was also able to produce a lot of these initial amino acids, including glycine, or actually a precursor to glycine. So in that sense, this is chemically possible without any life whatsoever. Unless we really send a mission here and get a sample of the atmosphere and try to see if there's anything inside, we're probably not going to know for sure if it's life. But there's still important stuff to learn from these discoveries. And one major discovery that the researchers mention in the paper is that, well, it's possible that Venus is actually undergoing its initial stages of biological evolution. In other words, it's quite possible that this is exactly what Earth was like billions of years ago when the life just started to evolve. And if so, we might actually use Venus as a kind of a very interesting biological experiment to see how life evolves on other planets, and to then start looking for similar signs somewhere else out there on other exoplanets. But no matter how you look at it, we kind of are still left with the same conclusion. We have no idea what's going on here, and the only way we can find out what's happening is by sending more missions, more investigations, and also conducting more very specific observations of the atmosphere of this beautiful planet. Because for all we know, these are just our biases. For all we know, there's no phosphine, or phosphine possibly is produced by volcanoes, and for all we know, it's not really glycine we just saw. But maybe, for example, sulfur oxide, which does seem to have very similar spectroscopic features. So in that sense, maybe these are just our biases and our desire to discover life somewhere out there, and we're desperately trying to find every sign of it somewhere near us. So until we actually go here, and until we actually find a way to collect the atmosphere and the samples from Venus, and possibly even analyze them or return them back to Earth, we're not really going to know for sure what's happening in the atmosphere and on the surface of this beautiful planet. Hello wonderful person, this is Anton, and today we're going to be talking about Venus once again, and about another paper that seems to justify what we originally discovered a few weeks ago. It looks like Venus possesses phosphine gas after all, the gas that, at least here on planet Earth, is uniquely produced by different types of life. It's never really produced by anything else. But what's even more shocking is that we originally got this data 42 years ago. In other words, we've always had this data, but it was just recently rediscovered. So let's discuss this in a little bit more detail, starting with this beautiful animation that was created by NASA around 6 to 7 years ago, demonstrating how one day we could actually go to Venus and even send actual astronauts there to explore, discover, and study the atmosphere of this beautiful planet. As you see in the simulation, it uses the beautiful invention from around 100 years ago. It uses zeppelins. Very, very large balloons with actual probes attached to the bottom of them, and the solar panels on the top of the balloon itself. In this case, the astronauts would be sitting in the cabin right here, with the large section behind this being the escape rocket that they would use to return back to Earth. And although it might sound crazy, this plan could definitely work because the technology behind all of this is already available to us. We're only just lacking the money to make this happen. Here's actually what the cabin might look like, and you can see there are 2 astronauts doing all kinds of scientific studies and at the same time communicating with the scientists back on Earth. And then, once they're ready to go home, all they have to do is launch the rocket and, of course, return back to Earth using a very similar method to how they got to Venus to begin with. So all of this sounds pretty easy, pretty incredible, and of course is something that we should be doing, but it hasn't been done, and honestly in the last few years, looks like NASA has lost all interest of going back to Venus. But that's of course until now, until we actually found signs of potential life there. And the first person to propose going back to Venus, and the first person who might actually do this, is of course the person we discussed in the last Venus video, Peter Beck, the CEO behind the company known as Rocket Lab that launches satellites in a similar fashion to SpaceX by Elon Musk. But that's of course the possible future. let's talk about the past for a second, specifically about how we used to explore Venus regularly and how we used to launch missions there pretty much every single year. One of such missions was known as the Pioneer mission, or more specifically Pioneer Venus Multiprobe, because the Pioneer mission itself included several missions and sub-missions in it, and it also lasted for something like 44 years, with the main goal initially being visiting the Moon and then going to other planets including Jupiter, Saturn, and later Venus. And the Pioneer Venus Multiprobe was extremely interesting because it was actually a combination of the orbiter with 4 different probes, 3 small ones like you see right here and 1 large one in the middle that contained 7 different instruments on the inside, including what's known as mass spectroscopy instrument, whose main purpose is to distinguish what sort of molecules and atoms are present in a sample. The way this apparatus works is pretty simple. First of all, we take the sample of whatever it is we're measuring, so for example, the air in the atmosphere of the planet, and then ionize all of the particles in it. We turn them into ions. In other words, these particles are now going to be affected by magnetic forces. We then accelerate these particles along some sort of a channel and cause them to suddenly turn using a magnet, as you see right here. Depending on the mass of the particle, certain particles will be able to turn much easier, but other ones, heavier ones, will not be able to turn as fast. I guess the best analogy here would be cars turning. A much heavier car is going to have trouble turning and will end up not turning as much as the much lighter car, which in this case will mean that the lighter object will end up moving on the bottom here, whereas the heavier object is going to be moving higher up. And as we start detecting where these ions end up landing, we can then start measuring the total molecular weight based on the measurements of something else we already know the weight of. So for example, let's just say because we know the molecular weight of oxygen, we can take ionized oxygen, do this to the molecules of that oxygen, and measure where it's going to land. And then we compare this to some of the other things we throw in here, which will eventually create something like this. Here we have the molecular weights of everything that was detected by this probe in the atmosphere of Venus, because as you might have guessed already, one of the probes was doing exactly that in the atmosphere of Venus back in 1978. And by looking at this old data from 1978, the scientists discovered that there were a few molecules in there that were not really well analyzed. In other words, some of the things that were originally detected by the Venusian probe did not initially make sense and were not really analyzed to the extent where the scientists knew exactly what they were. And so having looked at this old data once again, the scientists behind the paper you can find in the description below were able to quite definitively say phosphine was most likely present back then as well. Specifically right here at 33.992 AMU, which stands for Atomic Mass Unit, also known as Dalton, the measurement seems to match to the measurements of phosphine, which is exactly 33.997. And although the scientists behind this paper also mentioned that this is a very similar molecular weight or atomic weight of H2S, which is hydrogen sulfide, the original reports did not talk about phosphine or measure phosphine or actually even phosphorus at all. But in this analysis they also discovered that phosphorus was also there as well. And you can see that they found phosphorus in these samples as well. And although this is not maybe the best confirmation of the existence of phosphine, the amount discovered here is to some extent very similar to the amounts discovered in the previous paper we've discussed a few weeks ago, which altogether does mean that phosphine and phosphorus might indeed be present in the atmosphere of Venus. And if so, this is a huge mystery, for one very important reason mentioned in this paper. Venus has what's known as an oxidizing atmosphere. It has a lot of hydrogen peroxide, it has a lot of methane, it has a lot of nitrous oxides. All of these molecules generally would break up anything with certain chemical properties, such as what phosphine has. In other words, phosphine in general should not be able to survive without combining into something completely different. And this of course once again means that either A, phosphine is produced in some really strange way we've never even thought of before, so it's chemically produced by something else unusual, which also means that maybe we should go and figure out what's causing the creation of phosphine here, or B, more likely it's created by some sort of a organism. So the data from 42 years ago, from 1978, seems to confirm the discovery from just a few weeks ago. And all of these reasons are, of course, an excellent opportunity for us to go and see what's going on there. Now, luckily, at least one entrepreneur is already interested in going there, but we need organizations like NASA, organizations like the ESA, European Space Agency, JAXA, the Japanese, or the Chinese space agencies to go there and find something else to either prove or disprove the original discovery. In other words, I think we would all like to see this being a reality. Let's bring back the Zeppelins, let's bring back the technology from hundreds of years ago and make it work on Venus, and most importantly, let's eventually try to make the iconic Star Wars Cloud City a reality on Venus. That would be the ultimate achievement for humanity, at least for the 21st century. Let's hope that someone makes this happen, because seeing this would be absolutely epic. Hello wonderful person, this is Anton, and today we're going to be talking about our mysterious neighbor, Venus, the planet with extremely high temperatures close to about 500 degrees Celsius and extremely high pressures of about 93 atmospheres on the surface. The planet on which we might have potentially discovered phosphine, which I've discussed in one of the previous videos, but the discovery of which is still not entirely certain. The beautiful planet that sort of hinted on the existence of potential bacterial life in its upper atmosphere, with the recent discovery or potential discovery of phosphine being that one sign that a lot of scientists want to investigate. And because of these unconfirmed discoveries, for several months now there have been a lot of speculations about a potential future mission to Venus of some sort of really unusual and very innovative rover that's never been made before. A rover that's pretty much entirely mechanical, because that's the only way that such a rover could survive on the surface. And we've learned about the extreme conditions on the Venus the hard way. And specifically during the highest peak of space exploration for the Soviet Union during the early 80s, the Soviets sent several probes here that ended up landing, taking a few photos, but pretty much all of them became entirely disabled within only a couple of hours. All of which was of course the result of absolutely extreme conditions of the Venusian atmosphere. But this of course has not stopped the scientists, and for roughly a couple of decades now, various ideas have been proposed to try to explore this beautiful planet. But what makes the last few years, and especially the last few months, very exciting is the actual realization of several of these ideas and several of these propositions. First of all, a few months ago, NASA held a successful competition of various designs where it essentially offered people a few $1,000s if they could successfully design a mechanical rover that could operate and sense its environment by using no electrical components whatsoever. This one right here being the #1 winner. And you can learn more about this in one of the previous videos somewhere right there. And this of course allowed NASA to now sort of start planning this mission for real. We have the mechanical parts worked out, we have the potential idea for a rover that could land on Venus and possibly function here for a few months or even a few years. And now NASA has to figure out the last part, the part where it still needs to find a way to communicate with the rover, because you cannot really communicate with this with mechanical parts alone. We still need to have some sort of electrical thing going on the inside in order to create the electromagnetic waves for various radio transmissions. If you have a functioning rover on the surface but you have no idea what it's doing, the mission becomes kind of pointless. And so to add something to these designs, a lot of NASA scientists have recently been working on essentially creating a radio that can function in these conditions. And for the past few years, NASA has been running this really cool program known as GEER, or GEER, which stands for Glenn Extreme Environment Rig. This device is able to create conditions very similar to the conditions on the surface of Venus, and by placing various materials and various components inside this device, NASA scientists have been actually testing what survives and what doesn't. Not surprisingly, of course, a lot of modern materials we use in electronics do not survive for a very long time. They basically become completely useless within only a few minutes. And for silicon-based semiconductors like this one, they generally lose the ability to function as semiconductors really quickly as well. So for example, for a typical MOSFET, a semiconductor that's used in a lot of different components, if we use silicon here, it essentially becomes a permanent on switch once it reaches temperatures of about 300 degrees or even lower than that. And so on Venus, where temperatures are even higher, no electronics from Earth would function at all. And so radios that we have would not work here naturally. But because of these challenges and because of the requirement to have a radio for a rover, In the last few years, this has sort of been creating a completely new industry, an industry based on a new type of a semiconductor known as silicon carbide. And it looks like a lot of scientists using these silicon carbide components to create various types of electronics have been getting closer and closer to creating this radio for a Venusian rover. Now, to have a successful rover, obviously it has to be able to move around, it has to be able to explore, it has to be able to produce its own energy, which has already been sort of achieved using these mechanical rovers. And so it's really the communication part that's sort of the last missing component. And it looks like silicon carbide so far is the best solution to solve this problem. Now, silicon carbides are not new. They actually have been produced in large quantities back in 1890s, over 130 years ago. And it was Edward Acheson that accidentally produced a lot of them when he was actually trying to create artificial diamonds. But by combining silicon and carbon, instead he ended up producing silicon carbides. And interestingly enough, the first semiconductors produced back in 1906 were made from silicon carbides as well. But because silicon was much more efficient and also easier to produce, eventually it took over, and the semiconductor industry of today is entirely based on silicons and not on silicon carbides. And one of the reasons why silicon carbides are not very popular is because the crystals from which all of this is made are extremely difficult to produce. And it wasn't really until the late 90s when we finally learned how to make these silicon carbides crystals much easier. And even though this material has already been used in various other industries, it's not really that widely used in electronics yet. But it does make an excellent semiconductor. A semiconductor that has been shown to be able to survive extreme conditions, such as the ones on Venus. So unlike silicon semiconductors, silicon carbides can actually withstand temperatures up to about 1000 degrees Celsius, which would obviously allow these types of electronics to easily function on the surface of Venus. Now, because of this, for the past few years, NASA has been officially testing various types of electronics made from silicon carbides in this particular device that I previously showed you. And in one of the recent tests, it was able to survive in there for over a year, and that is actually really impressive. Especially because several other teams have already started working on integrated circuits made from this particular material. With one of the more impressive ones I found so far, about which you can learn in the article below, being this one right here known as Vulcan 2. And these integrated circuits are kind of reminiscent of some of the early days of modern electronics. Specifically, when the original MOSFET was invented back in 1950s, following this there was a huge explosion of various electronics, of various electronic devices that pretty much kickstarted the modern electronic era. All of which was kickstarted by these two wonderful people back in 1959. And then in the 60s, that's when the entire semiconductor industry just exploded. That's basically when Intel was found, that's when the Silicon Valley became a thing, and then you kind of probably know the rest. But that is exactly where we find ourselves right now with the silicon carbide semiconductors as well. The creation of these first integrated circuits using silicon carbides has a really high chance of exploding this new industry in the next few years. But not just because it will allow us to go to Venus. Venus is just sort of the requirement and the precursor. This industry has a lot of applications here on Earth as well, with some potential applications being extreme conditions in, for example, various turbines, various deep oil wells, all sorts of high temperature and high pressure conditions such as in various types of engines, or in various types of production facilities where there is a lot of pressure and temperature involved as well. It will essentially allow us to create various types of circuits and various types of electronics that can function in some absolutely extreme conditions where nothing was possible before. And according to the scientists behind this paper, they've already been able to create approximately 40 different integrated circuit devices that do function in these conditions. So essentially, it's the start of something absolutely incredible, assuming of course we do end up going to Venus, testing these devices there, and then take this to a next level here on planet Earth. Which of course should not really come as a surprise. A lot of modern inventions that we're using today, including things like MRI machines, things like Wi-Fi, all of these inventions originally started as something from astronomy or space exploration. And so because the scientists require these machines to function in these extreme conditions, it can definitely lead to a completely new technology and a completely new industry here on planet Earth as well. But even though these devices sound amazing, and even though we kind of are getting closer to being able to make them, with the idea of radio itself that can function on Venus being maybe about a year away, these particular semiconductors are still not perfect. For example, even a low voltage device still requires a lot more voltage than a typical silicon semiconductor, with the minimal required voltage being about 15 volts. And that's because of the nature of the silicon carbide itself. You can learn more about the details in the article in the description. At the same time, today we normally use what's known as PCB or printed circuit board, like the one you see right here, in order to create a platform for a lot of these integrated circuits to communicate and to function. But unfortunately for the radio on Venus and for a lot of these silicon carbide semiconductors, the production is entirely different. The chips in this case have to be attached to this really hard board using various gold and silver components, and previous components like aluminum no longer work. A lot of the board also has to be covered in titanium and even more silver, and copper that's normally used in modern boards no longer works either. And pretty much the entire board becomes a mixture of titanium, silver and gold. In other words, it's extremely expensive and also pretty challenging to produce using modern techniques. Which is of course really interesting because this type of a PCB can easily be bought online for a couple of dollars. There's a lot of services and a lot of YouTubers advertising those services where you can order like 20 of them for just 20 bucks or so. But for a Venusian PCB, you would basically have to spend a few $1,000s, if not more, just to make a tiny component to put in your radio. And so because of this, we're still really far from mass producing these devices, but we are only a few years, if not only a few months away, from being able to produce a fully functioning radio that would work inside one of these beautiful rovers that are probably going to end up on Venus in the next few years. And so that's kind of where we are right now. The radio is almost ready, the mission, even though theoretical, is definitely possible, and these rovers, if they become functioning and if they become a reality, will most likely take us to a completely new level of technology, assuming of course it all goes fine. Which of course also means that we absolutely have to push for this mission to happen. This will definitely take us to a new level, and this will definitely help us develop new technology that would be otherwise impossible. And in the process we might also discover a few things about Venus and our own planet that we didn't know before. With one of the bigger mysteries of course being, why is it that Earth still has water and has conditions where we can survive easily, and Venus became this? Super hot, very high pressure, a lot of acidic rain, and basically something that we are not going to be able to survive on. Questions that we'll hopefully be able to answer in the next few years. But until this mission happens, well, we can only hope. Let's hope that NASA does not abandon this, that they have the funding and they have all of the talent needed to produce these beautiful rovers and to send them to Venus, and let's hope that all of this happens within the next few years. For many years now, I've been speculating that we're going to find even more signs of life on Venus. And, well, looks like we got what I was asking for. Hello wonderful person, let's talk about this new discovery, very exciting discovery that suggests that there might be something happening on Venus after all. But I'm not going to go on a limb and say that this is life for sure, because it could be something else. Let's talk about this in a little bit more detail. And begin with a cautionary tale of the past from our neighbor Mars. You might remember back in the 90s, Bill Clinton made a pretty famous by now announcement suggesting that we found life on Mars, all of which was based on the discoveries coming from an asteroid we discovered in Antarctica that did come from Mars. This is sort of what we found there. These formations that you see right here from the asteroid known as ALH or Allen Hills 84001 were, according to some scientists, the signs that life, bacterial life, existed on Mars. And this, by the way, was back in 1996. Now back then I was about to start college and I got very lucky to work with one of the professors who was working with different asteroids and who was also trying to investigate ALH 84001, but he was doing it from a scientific perspective, trying to see if anything else can actually produce similar effects and trying to find some other signs suggesting that this is not life. Now, years later, actually decades later, we know that this was not signs of life at all. This was a chemical reaction that was successfully recreated in the lab as well. So in some sense, the premature announcement that we found life on Mars is a really good warning for us that we should not rush into saying that we found life on Venus as well. The one major thing that came out of this study was that we should not use morphology, or shapes in other words, to suggest that life was found. Because if something looks like life, it doesn't really mean it's life. On the other hand, if something smells like life, is it life? Well, chances are that it can still be just a chemical reaction, which is pretty much what we found on Venus now. So we found these molecules known as phosphines, not to be confused with phosphines, which apparently is spelled just a little bit different but means a completely different thing. So we're talking about this, not this. This here refers to a psychological perception of light without any light being produced. So in other words, this is a completely different concept. This here is a molecule, and this molecule is also extremely toxic. As a matter of fact, in the last few years, several major incidents occurred when this molecule leaked somewhere, resulting in several fatalities, and this is something that actually happens every few years here and there. So this is a pretty dangerous gas. But how can a dangerous gas be connected to life? Well, it turns out that here on planet Earth, the only way we've discovered that this gas is produced is with certain bacteria, so-called anaerobic bacteria that does not require oxygen. A lot of different types of these anaerobic bacteria exist on our planet. Some of them can even be found inside of you right now, inside of your guts, and they do produce all sorts of different gases. By the way, completely not related, but that's exactly where the gas comes from when you pass gas. It's the anaerobic bacteria producing all sorts of stuff inside of you. But certain bacteria do produce phosphine, and for what reason we don't really know. There have been speculations that maybe it's used as a kind of a protection. Because it's toxic, maybe some bacteria use it to kind of cover their area with it so that other bacteria don't get in there. And so it could be used as a sort of a protection for various types of bacteria, or it could be just their waste. We don't really know what phosphine is for. But we do know that on Earth, no geological or chemical process ever produces it. It's always bacteria. It has even been suggested that phosphine is a very important part of the phosphorus cycle on our planet. Essentially, this is how phosphorus is recirculated and reintroduced back for other life to use. But all of these are very early assumptions because we just don't know enough about it. But then again, we've actually found phosphine on other planets. Specifically, our large cousins Jupiter and Saturn. Both of these do contain a lot of phosphine. And so today the scientists believe that it can be produced in extreme conditions in these gas giants. Extreme pressures, possibly extreme temperatures do produce phosphine in inorganic ways. Which once again takes us back to Venus. As it usually happens in science, this was a completely accidental discovery. As a matter of fact, the scientists were almost doing the opposite. They were using this beautiful telescope known as James Clerk Maxwell Telescope to try to rule out extreme scenarios and to try to establish a kind of a base for what we should be looking at when looking at other planets. Now this telescope is able to observe in sub-millimeter range and is able to see certain wavelengths in extreme precision. And it just so happens that one of these wavelengths is apparently the absorption spectrum of phosphine as well. Now, this is where I actually don't know enough about chemistry to speculate that maybe there's another chemical out there that could be similar to phosphine in that sense. So if you do know enough about chemistry, please let me know in the description, because maybe it's just a chemical that's very similar to phosphine, has a similar absorption spectrum that's not phosphine. Anyway, long story short, they used the telescope, they looked at Venus, specifically the absorption spectrum, and they saw the spectra that are very similar to phosphine. And this of course was very unexpected. They did not expect to find this in the atmosphere of this planet. Now you might have seen my older video from a few months back based on another paper that very strongly suggested that phosphine can only mean alien life. And in retrospect, I sort of regret making the strong statement, because now I'm doubting myself. What if there are ways for phosphine to be created inorganically? And what if Venus actually has one of these conditions for phosphine to be formed? Now, right now, our understanding of how chemistry works on other planets is not particularly good, because we haven't really been able to create a lot of situations where Venusian conditions, for example, are recreated. And here we are of course talking about 93 atmospheres of pressure and almost 500 degrees Celsius of temperature. So in that sense, maybe there is something going on here that makes this possible without any bacteria whatsoever. But then on the other hand, if you've been on the channel long enough, you probably know that I'm a strong believer and a proponent in thinking that there is definitely life on Venus. I'm just not entirely sure that this was the sign of it. maybe one of the signs, but not a definitive sign. And by the way, a lot of the speculations and a lot of the ideas behind the life of Venus began when we started observing unusual formations inside the clouds of Venus that were absorbing the light coming from the sun in a very unusual and very peculiar manner. These so-called light absorbers, as they're known today, are still a mystery and are definitely yet another sign that life could be present on Venus after all. But the other obvious reason why we believe life is totally possible here is because life can exist in the upper atmosphere. One of the previous papers I've mentioned had this beautiful illustration in it suggesting that, well, right around here, around 50 to maybe even 70 kilometers above the ground, is where life can definitely exist and even thrive, because we get about 1 atmospheric pressure, which is similar to Earth, and the temperatures are also very similar to what we have on the surface of the planet. The only difference being that it's also a little bit more acidic. But we also know that here on Earth we have extremophiles that absolutely thrive in acidic conditions. We found them everywhere on the planet, especially in extreme, very hot, very acidic places. The most famous example, of course, is the Yellowstone National Park, which is what you see right here. And these bright colors are all bacterial in nature. This is all produced by all sorts of different extremophiles. So in that sense, finding life in there is totally not unusual. It's just we haven't really had enough signs of life yet. We have visual signs, now we have chemical signs, but we're still missing some. In other words, it can still be a chemical reaction of some sorts. And because we've learned a lesson from the Martian announcement that was premature and did not involve any life found, we now need to take a little bit more caution. But luckily for us, there's at least one mission that's currently very actively investigating the potential presence of life on Venus, at least from the perspective of atmosphere. Japanese Akatsuki is still there, it's still actively getting a lot of data from Venus, and in the next few years we're going to get enough data from the upper atmosphere of Venus to maybe make other conclusions and come up with some other explanations for what we're observing here and why phosphine is present. Maybe it's some sort of a solar reaction for all we know. So we're not going to rush into saying that this is definitely life. It's very likely life, like I've been saying for years, but not 100% yet. And the only way we're going to be certain about this being life is only if we launch something like this to Venus that's been suggested for decades now. As a matter of fact, Soviet Union was able to launch a balloon with an actual detector and a sensor back in mid-80s. That was like 35 years ago, I think, even more than that. So the technology is definitely there. Why haven't we done it yet? Well, there is no political pressure, there is no public interest, and most importantly, there's just no will. No desire to go there from any major organization. And those that possess the ability to go and have the will are going to the wrong place. Elon Musk? Seriously. Mars? No. You gotta go to Venus. But let's just assume for a second that this is indeed life and they're basically eating all of the stuff in the atmosphere and producing phosphine for one reason or another. How are they doing it? So there are still quite a lot of mysteries here. First of all, where is the hydrogen coming from? Phosphine is basically phosphorus and hydrogen, and we don't really know where either one of these molecules is coming from in the atmosphere. We know, for example, that there is oxygen, and the oxygen is being lost by the planet. We've seen this as a kind of a tail coming from Venus. And in some sense, we know that there are acidic conditions, which usually include hydrogen. So whatever is happening there has to be getting hydrogen from these acids. And right now, once again, the best explanation turns out to be bacteria yet again. Acidic extremophiles specifically. They would love to use acid and get all of the hydrogen from those acids. But what about phosphorus? Well, on Earth, phosphorus is in a kind of a cycle. The bacteria get phosphorus from other organic matter that they consume. Is that what's happening on Venus as well? Do they have other organic organisms circulating in the atmosphere that this bacteria eats? That's kind of what sort of is being implied here. At least that's if we use our earthly comparison. Chances are, whatever is happening here is, for the lack of a better word, alien. But what's really interesting about this discovery is that the scientists found a lot of the phosphine in the atmosphere. The amount they discovered here translates to about 20 parts per billion. And though it doesn't sound like a lot, according to the scientists behind this paper, that's about 10,000 times more than any chemical reaction would produce anyway. So if this is a chemical reaction, it's an extremely active chemical reaction that once again we don't really know how to explain right now. On top of this, phosphine doesn't really stay stable for a very long time, especially when there's a lot of ultraviolet light, such as there is in the upper atmosphere of Venus. In this case, phosphine molecules end up being destroyed and consumed by either water or carbon dioxide, and there's a lot of carbon dioxide on Venus. So in that sense, unless something is replenishing phosphine in the atmosphere, it shouldn't exist once again. In other words, the more we try to explain this as some kind of a chemical reaction, the more it seems that it's not. It is very difficult for us to currently explain this without invoking alien life, which honestly makes me super happy. This is one place I was hoping would find life for a very long time. But despite my excitement and despite my enthusiasm, I'm still going to be a little bit skeptical, simply because of that announcement by Bill Clinton, which to this day is still there on NASA's page. And that is a good reminder for us to be really careful this time. So even though maybe in my heart I believe that it's life, my brain tells me otherwise. My brain tells me to be very careful. And hopefully your brains will tell you the same. But hypothetically, let's assume that this is life. Well, if this is life, we suddenly have a lot of other topics to talk about. For one, panspermia. Did this life come from Earth? Or vice versa, did the life on Venus create life on Earth later on? Many modern studies suggest that Venus looked something like this billions of years ago, so it did have habitable conditions. If it was created here first and then transferred to Earth, that would actually be really exciting for us to study, because we would get to see what ancient bacteria looked like. Also, since according to the scientists the detection of phosphine happened exactly in the habitable zone of the atmosphere of Venus, the follow-up question here is of course, well, what other types of life are we going to find here? It's very unlikely that there's just going to be one type of a microbe living here. It's very likely that it's a community that sort of circulates and recycles materials from one another, which would of course solve the mystery of where the hydrogen and the phosphorus come from. So definitely a lot of exciting questions, possibly a lot of exciting studies and discoveries in the next few years. But what I'm hoping for is more missions. A lot more missions. Honestly, forget about Mars, at least for the time being. Let's focus all of our attention on Venus and try to find what we can discover there. Now, NASA currently has at least 2 major missions planned for Venus, but they're still in a far enough future. One of them, the VERITAS mission, is going to hopefully have a lander that will hopefully explore the surface of Venus. A few months ago I made a video that you can find somewhere above my head that talked about the absolutely incredible competition and designs that NASA was able to collect from all over the planet that are hopefully going to result in an incredible new invention, essentially a kind of a robot, mechanical robot that has no electronics on the inside, that's going to go to Venus and explore it. But that's in the future, possibly in the next 5 years or so. For now, we don't really have anything going on for the next 2 years, so this is where we need private companies. Possibly SpaceX, maybe some other company, Electron, maybe you guys. Anyway, someone needs to go there and find out what's happening. And all we need is just a tiny balloon. Something that can go into the upper atmosphere, grab a few samples, and return them back to Earth. The Soviet space program was able to achieve this back in the 80s, but they had an active balloon system. So building from that should not be too difficult. We definitely have the technology for this. So if all goes well, in the next 5 years, we'll have the answer to the question of, is there life on Venus? Hello wonderful person, this is Anton, and today we're going to be talking about a confirmation and an actual picture of the mysterious ring of Venus. Well, okay, it's not really mysterious, but there are some mysteries in regards to it. And specifically, it's this ring right here that we discussed approximately a couple of years ago, when the scientists using different telescopes identified the presence of this unusual ring, and here we're just talking about dust ring, present in the orbit of Venus, but also present in the orbit of Mercury, and actually also present in the orbit of Earth as well. In other words, pretty much all planets we believe have these rings, whose origin is not really well understood. Although generally we can assume that their origin is related to the presence of interplanetary dust. But where this dust comes from and what exactly makes it form is of course another question. Now, not so long ago I made a video talking more about what's known as the zodiacal light, which is this beautiful shine that you usually see right before dawn in certain locations on the planet at certain time of the year. And although originally a lot of scientists believed that this was probably produced by asteroids and comets, as they essentially emit a lot of dust into the interplanetary space. The more recent analysis suggested that this is actually a dust ring from Mars, and there was a lot of really strong evidence to support this argument. And so basically now we know that all of the planets seem to have them for one reason or another. The one around Earth, for example, was identified back in 1994, and the one in the orbit of Mercury was identified approximately 3 years ago and analyzed quite thoroughly as well. But this time, almost completely by accident, the scientists using the Parker Solar Probe, the one that we talked about sometime a few years ago, that's basically the probe sent to study the Sun, and that's going to be the closest probe to the Sun in 2024, as it moves closer and closer to the Sun, orbiting in such a way where Venus actually lowers its orbital parameters every single time the probe passes in such a way where the Venus gets to lower its orbit. And so eventually in 2024, specifically in December 2024, the Parker Solar Probe is going to beat the record for, well, basically the closest distance to the Sun. It's also going to be moving extremely fast at this point, setting another record for the fastest spacecraft. But because it's called Parker Solar Probe, its main mission is of course to study the Sun and to observe the Sun, and to then also study various solar emissions such as the solar wind, the emissions that we've never really seen from this particular location in the solar system. So in that sense, the main purpose of this mission is not really to study dust at all. As a matter of fact, when the scientists are trying to study the emissions coming from the Sun, they generally analyze the data by trying to cancel out all of the other interplanetary dust, mostly because it's actually extremely bright. And also because there is a tremendous amount of dust everywhere in the solar system, which is also, by the way, one of the mysteries. We're not entirely certain what creates all of this dust. If it's comets or asteroids, there's still way too much of it, and if it's coming from planets like Mars, then there's just not enough of it. I guess in some sense it could be a bit of both, but there's no evidence right now to suggest that it's coming from one source or the other. Anyway, one of the instruments on the probe is this right here, and it's known as WHISPER. It's essentially a telescope, and it stands for Wide Field Imager for Solar Probe. Here's actually the first ever picture taken by this instrument back in 2018, and its main purpose is to basically try to study the solar wind by looking at the dark patches of the night skies away from the Sun. But in order to do this effectively, the scientists have to first of all cancel out all of these stars you see in the picture, and also try to cancel out any kind of a dust or obviously reflections from the dust present in the picture. Normally this is done automatically, and you can actually set up a filter to try to successfully take pictures without really dealing with this every time. But these settings have to be preset depending on the location of the probe. But remember how I mentioned that the probe is actually using Venus to try to lower its orbit? Well, right now the probe is doing its 7th orbit around the Sun, but back when it was doing the 3rd orbit, it actually had to change its orientation just a little bit in order to initiate its engines so that it can pass near Venus and thus lower its orbit even more. In other words, it had to initiate a maneuver so that it can change its orbital parameters. But because of this, it also slightly changed the orientation of cameras, which then sort of invalidated the presets used for previous pictures. And so the filter wasn't actually blocking all of the dust anymore, and completely by accident, when they took a picture trying to study solar wind again, the picture was able to reveal the circumsolar dust ring located in Venusian orbit. The ring itself being this really thin line you see right here. This is Venus, this is Mercury, and right here we have Earth. And based on the initial calculations, all of this suggests that the ring itself is roughly around 10% more dense compared to the general density of the interstellar dust in the region, while also being roughly around 1% brighter than the interstellar dust nearby. So it's not really that bright, but it's bright enough to be seen with a telescope. And here they were also able to calculate its total thickness. This here is roughly around 6.5 million kilometers. That's about 22 times the distance of Earth to the Moon. And that of course suggests that there's a lot of dust here. Which is, by the way, one of the mysteries. One of the studies that came out not so long ago suggested that the excess of dust located in this region could be maybe explained if Venus was actually sharing its orbit with several hidden asteroids. If there are asteroids here, such as what we would call Trojans, similar to these Trojans located in the orbit of Jupiter, but obviously Trojans that we haven't discovered yet, this would explain why there's so much dust in the orbit of Venus. Because the only other alternative explanation here is that maybe it's emissions from Venus itself, but in this case it's way too much, it's more than expected, and so it doesn't really explain where all of this is coming from. But because of these discoveries, now the scientists know what to look for and how to look for it. So there's definitely going to be follow-ups once they reposition the solar probe and once they're able to take more pictures. More importantly for this mission though, as the probe gets closer and closer and closer to the Sun, up until 2024 when it finally makes the closest approach, the scientists expect that the probe is going to reach a zone known as the dust-free zone, something that's actually quite hypothetical, but something that is expected to exist in the region extremely close to the Sun itself. The models right now predict that at some point really close to the Sun, the dust is just unable to exist anymore, mostly because it evaporates or because the solar wind just sort of expels it from the area. Now, discovering this region around the Sun would be very important because it would definitely confirm the theories we have about the Sun, and it would also confirm the theories about the interaction between the Sun and the interplanetary dust. But at the same time, it would maybe help the scientists answer the question of where all of this dust is coming from. There's just a little bit too much of it to just come from meteorites and comets, and so if this dust is coming from the interstellar space, from basically outside of the solar system, that's even more exciting. That means that we can learn about the universe around us, or at least about some of the nearby stars, by capturing these particles and by studying them in more detail. And since all of this dust is also technically the building blocks of everything, planets, stars, also you and me as well, it's basically like studying the material that we're all made out of. It will help us identify how the gas is carried between the star systems and how it basically provides the environment necessary for everything in the solar system to grow and to develop.